Today we'll discuss ISI's 2021 QROR objective paper, and the first question is, if NC0 plus NC1 into NC1 plus NC2 up to NCn-1 plus NCn equals K into NC0, NC1, NCn-1, we need to find value of K. Now on the left hand side, we'll take NC0, NC1, NC2 up to NCn common. Then we can write NC0 into NC1, NCn-1, and here it will be 1 plus C1 upon C0, 1 plus C2 upon C1, and 1 plus Cn upon Cn-1. Now we compare it with the right hand side. That means this is your K. Now we can write this K as this product R varies from 1 to n, 1 plus NCR upon NCR minus 1. Now we can write this as this product from 1 to n, and 1 plus NCR upon NCR minus 1 is n minus R plus 1 upon R. Now we simplify it, we can write this as n plus 1 upon R. Now we'll put the value of R. It will be n plus 1 upon 1 into n plus 1 upon 2 up to n plus 1 upon n, which is n plus 1, n plus 1, n plus 1, n times n upon 1 into 2 into 3 up to n, which is factorial n. So value of K is n plus 1 to the power n upon factorial n, and that's your option A. Now question number 2 is, we are given if g dash x equals fx, we need to find this integral x cube into fx square dx. Now if g dash x equals fx, we can write integral of fx dx, it will be simply gx. Now in order to solve this question, we need to solve this integral, which is 2x into fx square dx. Now if we take x square as t, we can write this as ft dt, and integral of ft dt will be gt plus c, which is gx square plus c. Now we'll start solving this question. Now we'll write this integral as 1 by 2 x square into 2x fx square into dx, and we'll solve this integral using by parts. So this is our first function and this is our second function. So we can write this as 1 by 2 and then x square as it is. Integral of this function is gx square minus, and then this integral sign, derivative of x square is 2x into this integral, which is gx square dx plus c dash. So it will be 1 by 2 x square gx square minus, now 2 and 2 will cancel, so it will be x gx square dx plus c, and which is your option B. Now question number 3 is, consider the system of linear equations x plus y plus z equals 5 and 2x plus 2y plus 3z equals 4, then which of the following is correct? Now these two equations, they'll represent two planes in 3D space. Now for this first plane, direction ratios of the normal are 1, 1 and 1, and for the second plane they are 2, 2 and 3. Now their ratios are 1 by 2, 1 by 2 and 1 by 3, which is not equal. So that means these two planes, they are non-parallel planes. Now if the two planes are non-parallel, then these two planes, they'll intersect in a line. So there'll be infinitely many points which satisfy this system of linear equation. So this system has infinitely many solutions, and that's your option C. Now question number 4 is, if f is a continuous function such that fx equals 2 minus under root x plus 4 upon sine 2x, we need to find value of f0. Now f0 will be this limit x tends to 0, 2 minus under root of x plus 4 upon sine 2x. Now this is 0 upon 0 form. Now we rationalize it. So we write 2 plus under root x plus 4 upon 2 plus under root x plus 4, which is this limit x tends to 0. Now here will be 4 minus x minus 4, which is minus x upon sine 2x into 2 plus under root of x plus 4. Now here we'll multiply it with 2 and we'll divide it with 2. Now 2x upon sine 2x, it is 1. And if we put x as 0, it will be 2 plus 2, 4. So this value will be minus 1 by 8. So if this function is continuous, then the value of f0 must be minus 1 by 8, and that's your option A. Now question number 5 is, suppose A, B, C are in AP and A square, B square, C square are in GP such that A is less than B is less than C and A plus B plus C is 3 by 2. We need to find value of A. Now if A, B, C are in AP, then 2B equals A plus C. Now if we put the value of A plus C here, we'll get 3B equals 3 by 2. That is, the value of B is 1 by 2. Now if we put B as 1 by 2, we'll get this equation as A plus C equals 1. And from this GP, we'll get B to the power 4 equals A square C square, or A into C is plus or minus B square, which is plus or minus 1 by 4. Now we'll put the value of C here. So we'll get A into 1 minus A, and it'll be plus or minus 1 by 4, which is 4A minus 4A square equals plus or minus 1. Now we'll subtract 1 both sides, and here if we take minus common, we can write minus 2A minus 1 whole square will be plus minus 1 minus 1, or 2A minus 1 whole square will be equal to 1 minus plus 1. Now 1 minus 1 is 0 and 1 plus 1 is 2. So either we'll get A as 1 by 2, or we'll get 2A minus 1 as plus or minus root 2. Now A cannot be 1 by 2 as A is strictly less than B. So from here we'll get this condition that A is 1 plus minus root 2 by 2, which is 1 by 2 plus minus 1 by root 2. Now this A is less than 1 by 2, that means value of A must be 1 by 2 minus 1 by root 2, and that's your option D. Now the sixth question is, we need to find set of all A satisfying the inequality 1 upon under root A, and then this integral from 1 to A 3 by 2 under root x plus 1 minus 1 by under root x dx, and it is less than 4. Now we can write this as 1 upon under root A, and here it will be 3 by 2 x to the power 3 by 2 upon 3 by 2, which will cancel from 1 to A, and then plus x from 1 to A, and then minus x to the power 1 by 2 upon 1 by 2 from 1 to A, and it is less than 4. So it will be 1 upon under root A, and here will be A root A minus 1 plus A minus 1, and here it will be 2 root A plus 2, that is less than 4. Now 2 and minus 2 will cancel. We can write this as A plus under root A minus 2, it is less than 4, or under root A square plus under root A minus 6, it is less than 0, which is root A plus 3 into root A minus 2, it is less than 0. Now this is always positive, so we can remove it. From here we can write under root A is less than 2, or A is less than 4. And since we have this square root sign, so this A, it must be greater than 0. So the set of values of A will be from 0 to 4, and that's your option D. Now question number 7 is, you are given a matrix A whose order is 4 cross 4 such that both A and adjoint A, they are non-null matrices. Now if determinant of A is 0, then we need to find rank of A. Now if determinant of A is 0, then rank of A, it cannot be 4. That is, the rank of A, it should be 3 or less than 3. Now we are given that adjoint A, it is not a null matrix. It simply means there will be at least one minor which is non-zero, and it means that rank of A, it must be 3, and that's your option C. Now question number 8 is, a person throws a pair of fair die. If the sum of numbers on the die is a perfect square, then we need to find the probability that number 3 appeared on at least one of the dice. Now let this be event A and let it be event B. Now A is when sum of numbers on the dice is a perfect square. Now it will be perfect square if the sum is 4 or this sum is 9. Now it can be 4 if it is 1, 3, 2, 2 and 3, 1, and it will be 9 when we have 6, 3, 4, 5, 5, 4 and 3, 6. Now we need to find this probability B by A, and probability of B by A is probability of B intersection A upon probability of A. Now B intersection A is sum on the numbers must be a perfect square and it should have at least 1, 3. So it will be 1, 3, 3, 1, 3, 6 and 6, 3, which is 4 by 36, and probability of A is 7 by 36. So this required conditional probability is simply 4 by 7, and that's your option B. Now question number 9 is, we are given C0, which is set of all continuous functions f, and C1, which is set of all differentiable functions g, such that derivative g dash is continuous. Now if we define a function t from C1 to C0 given by t equals g dash, then we need to find which of the following options is correct. Now this function, clearly it cannot be a one-on function, because we can always consider two functions which differ only by a constant, and in that case both of them, they'll be mapped to the same function in C0. So this function is not a one function. Now what about onto? Now fundamental theorem of calculus says for any f in C0, we can define a function fx which is given by this integral from 0 to x ft dt. And in this case, this f, it is inverse image of f under t. That means this function t, it is an onto function. So this function t is onto but not one-to-one, and that's your option C. Now question number 10 is, we are given S, which is a set of n elements, and we need to find number of ways in which n distinct non-empty subsets x1, x2 up to xn can be chosen such that x1 is a subset of x2 and it goes on up to xn. Now since we need n distinct non-empty subsets, it is possible if and only if x1 has one element, x2 has two elements, x3 has three elements, and xn has all the n elements. Now since x1 is a subset of x2, so this x2 will contain this one element of x1, this x3 will contain these two elements of x2, and xn will contain n minus 1 elements of xn minus 1. Now we need to find in how many ways we can choose these subsets. Now for this x1, we need to choose one from n elements, and it can be done in nc1 ways. Now for x2, we need to choose two elements, but then we already have one. So from the remaining n minus 1 elements, we have to select one element. Now for x3, we already have two elements. We just need to select one from the remaining, which is n minus 2 c1, and will continue up to 1 c1. Now this is n into n minus 1 into n minus 2 up to 1, which is nothing but factorial n. So the total number of ways is factorial n, and that's your option C. Now in question number 11, we are given the sequence which is fn x equals x to the power n cos 2 pi nx when x belongs to -1 and +1. And we need to find this limit n tends to infinite f nx. Now, if we consider this first case, when the value of x is 1, we can write f n1 as 1 into cos 2n pi, and cos 2n pi is 1. So in this case, limit n tends to infinite f nx will be simply 1. So for x equal to 1, this limit exists. Now we'll consider the second case when the value of x is -1. Now we'll have fn -1 and it'll be -1 to the power n cos 2n pi into -1, which is -1 to the power n. Now if we take this limit n tends to infinite fn x, then in that case, this value, it can be either -1 or +1. That is, we'll get an oscillating value. So in this case, this limit, it does not exist. And finally, when x lies between -1 and +1, in that case, this mod xn cos 2n pi x will be mod of x to the power n into mod of cos 2n pi x. And if we take this limit n tends to infinite, now this is oscillating value from 0 to 1, and since mod x, it lies between 0 and 1, this is 0. Now 0 into anything finite is simply 0. In this case also, this limit exists. So this limit will exist if and only if x belongs to the interval where -1 is not included and 1 is included, and that's your option D. Now question number 12 is, we need to find number of distinct even divisors of this product. Now this is factorial 1 into factorial 2 into factorial 3 into factorial 4 into factorial 5. Now this is 1, this is 2, this is 3 into 2. Now factorial 4 is 2 square into 3 into 2, and factorial 5 is 5 into 2 square into 3 into 2. Now this is 2 to the power 8, 3 cube into 5. Now we need to find number of distinct even divisors. Now if this divisor is an even number, then from 2 to the power 8 we'll have 8 choices, because choices, they start from 2 to the power 0 to 2 to the power 8, and since it is an even number, it should have at least 1 2. So total number of choices is 8. Now for 3 to the power 3, number of choices is 4, and for 5 to the power 1, number of choices 2. So it will be 8 into 8, which is 64, and that's your option C. Now question number 13 is, a straight line passes through the intersection of lines given by 3x minus 4y plus 1 and 5x plus y minus 1 equals 0 and makes equal intercepts of the same sign on the coordinate axis. We need to find equation of this straight line. Now first we'll find equation of family of lines which passes through point of intersection of two given lines. So we can write this as 3 plus 5 lambda x plus minus 4 plus lambda y, and then 1 minus lambda equals 0. Now slope of this line is minus coefficient of x, which is 3 plus 5 lambda upon minus 4 plus lambda, and since it makes equal intercepts of same sign, its slope must be minus 1. So this minus and minus will cancel, we'll get 3 plus 5 lambda will be minus 4 plus lambda, that is 4 lambda equals minus 7. The value of lambda is minus 7 by 4. Now if we put the value of lambda in this equation, we'll get 3 minus 35 by 4 into x plus minus 4 minus 7 by 4 into y, and then 1 plus 7 by 4 equals 0. So here will be 12 minus 35 is minus 23x. And then minus 16 minus 7 is minus 23y. And then 7 plus 4 is 11 equals 0. So equation of this line will be 23x plus 23y minus 11 equals 0. And that's your option D. Now question number 14 is, suppose G is a cyclic group and AB belongs to G. And let this cyclic group be generated by this element P. Now there does not exist any x such that x square equals A, and there does not exist any y such that y square equals B. Then which of the following options is correct? Now if there is no element such that x square equals A, then this A, it must be an odd power of this generator P. So this A is of the form P to the power 2n plus 1. In the same way, B must also be an odd power. So let it be P to the power 2m plus 1. Now we multiply them, we can write AB as P to the power 2n plus 2m plus 2, that is P to the power m plus n plus 1 whole square. Now this is some element, say G. So in this case, we'll get G square equals AB. So there exists an element G in G such that G square equals AB, and that's your option A. Now question number 15 is, let D be the triangular region in the xy plane with vertices at 0, 0, 0, 1 and 1, 1. So we have this triangular region. So this is 0, 0, this is 0, 1 and this is 1, 1. And in this region, we need to find value of this double integral. Now this is y is equal to x line. Now this point is x comma x, and this point will be x comma 1. So we can write this integral as this integral from 0 to 1, and then for y it will be from x to 1 2 upon 1 plus x square dx into dy. So it will be this integral from 0 to 1 2 upon 1 plus x square, and then from x to 1 dy into dx. Now we integrate this, we'll get this as 1 minus x. So it will be this integral from 0 to 1 2 times 1 minus x dx upon 1 plus x square. So it will be this integral from 0 to 1 2 dx upon 1 plus x square, and then minus this integral from 0 to 1 2x dx upon 1 plus x square. Now this is 2 times, and then tan inverse x from 0 to 1, and then minus log 1 plus x square from 0 to 1. So it will be 2 times. Now tan inverse 1 is pi by 4 and minus log 2. So value of this integral will be pi by 2 minus log 2, and that's your option B. Now question number 16 is, we need to find number of saddle points of this function. Now if we find fx will be 8x cube minus 2x, and if we put it equals to 0, we'll get x as 0, x as 1 by 2 and x as minus 1 by 2. And if we find fy, it will be 6y, and if we put it equals to 0, we'll get y equals 0. So we get 3 critical points, 0, 0, 1 by 2 comma 0 and minus 1 by 2 comma 0. Now we'll find fxx will be 24x square minus 2, fyy will be 6, and then fxy, and which is 0. Now we'll find h, which is ab minus c square. So this is a, this is b, and this is c. Now ab minus c square will be 24x square minus 2 into 6. Now for 0 comma 0, this h will be minus 12 and which is less than 0. So this 0, 0 will be a saddle point, and for plus minus 1 by 2, 0, this h, it will be 24 into 1 by 4, which is 6. 6 minus 2 is 4. So 4 into 6 is 24, which is greater than 0. So here there won't be any saddle point. So number of saddle points for this function will be simply 1, and that's your option A. Now question number 17 is, suppose A and B are two square matrices such that the largest eigenvalue of AB minus BA is positive, then the smallest eigenvalue of AB minus BA is. Now since we are talking about smallest and largest eigenvalues, that means all the eigenvalues of this matrix AB minus BA, they are real. Now we know that trace of AB minus BA is 0, and trace is nothing but sum of all the eigenvalues. So it simply means that sum of all the eigenvalues is 0. Now we are given that this largest eigenvalue is positive. Now sum of all the eigenvalues will be 0 when this least value, it should be negative, otherwise it cannot be equal to 0. So the smallest eigenvalue of AB minus BA, it must be negative, and that's your option B. Now question number 18 is, we are given this series. Now we need to find convergence and divergence of this series. Now first we'll use ratio test. We'll find limit n tends to infinite Tn plus 1 upon Tn, and it'll be this limit n tends to infinite. Now Tn plus 1 will be 369 up to 3n, and 3n plus 1 upon 7, 10, 13 up to 3n plus 4 into 3n plus 7 x to the power n plus 1 upon Tn, which is 369 up to 3n upon 7, 10 up to 3n plus 4 into x to the power n. Now all these terms, they'll cancel. We'll get this as this limit n tends to infinite 3n plus 3 upon 3n plus 7 into x. Now we take this limit n tends to infinite, we'll get this as x. Now this series will diverge if x is greater than 1, and it will converge if x is less than 1. And at x equals to 1, this test fails. Now when this ratio test fails, we'll use Reb's test. We'll find limit n tends to infinite n into Tn upon Tn plus 1 minus 1. So it'll be this limit n tends to infinite n, and then here it will be 3n plus 7 upon 3n plus 3 into 1 by x, and x here is 1 minus 1. So it will be this limit n tends to infinite n, and here will be 4 upon 3n plus 3, which is 4 by 3. That means this series, it converges for x equal to 1. So answer to this question will be, this series, it converges for x lying between 0 and 1, where 1 is included, and it diverges for x greater than 1, and that's your option A. Now question number 19 is, we are given an eigenvalue of A as -1, and we are also told that A plus I is equal to this matrix. Now from here we can write this matrix A as this matrix minus identity matrix will be 0, 0, -2, 0, -1, 0, and 0, 0, and -1. Now we need to find eigenvector corresponding to this eigenvalue -1. So we can write ax equals minus x, where this x is a, b, c. Now we can write this as a, which is 0, 0, minus 2, 0, minus 1, 0, 0, 0, minus 1 into ABC, and will be equal to minus ABC. Now we multiply these two matrices, we can write minus 2C minus B minus C will be equal to minus A minus B and minus C. Now we compare the two matrices, we'll get A equals 2C. Now in this case, B can take any value and then A must be equal to 2C. So if C is T, then A must be 2T and B can take any real value. So that means answer to this question is this option B. Now question number 20 is, we need to find number of real roots of this polynomial, which is x cube minus 2x plus 7 equals 0. Now let it be some function f, which is x cube minus 2x plus 7. Now we find f dash x will be 3x square minus 2 and will be equal to 0. That is, value of x is plus or minus root 2 by 3. So one of the value is root 2 by 3 and the other value is under root 2 by 3. Rightmost is plus, minus and plus. So it will have a maximum at minus root 2 by root 3 and it will have a minimum at root 2 by root 3. Now we find value of this function at minus root 2 by 3. So it will be minus root 2 by 3 and then x square minus 2, and x square minus 2 will be 2 by 3 minus 2 and then plus 7. So this value will be 7 plus 4 root 2 upon 3 root 3. And in the same way, value of f root 2 by 3 will be 7 minus 4 root 2 upon 3 root 3. Now both the values, they are positive. So if we draw an approximate graph, then its maxima will occur at minus root 2 by root 3 and its minima will occur at plus root 2 by root 3, and both maxima and minima, they are positive. So this graph will be drawn approximately like this, which means that this graph will intersect x-axis at only one point. So number of real roots of this polynomial will be simply 1, and that's your option B. Now question number 21 is, suppose phi is the solution of this differential equation such that phi 0 is 1 and phi dash 0 is 5, then which of the following option is correct? Now we are given a second order differential equation. We can write this as m square minus m minus 2 equals 0. So it will be m minus 2, m plus 1 equals 0. So value of m is 2 or value of m is minus 1. So we can write this phi x as a into e to the power 2x plus b into e to the power minus x. Now we're given that phi 0 is 1. So phi 0 is a plus b, and it is equal to 1, and phi dash 0 will be 2a minus b, and it is 5. Now if we'll add them, we'll get a as 2, and if the value of a is 2, value of b is minus 1. So we can write this phi x as 2 into e to the power 2x minus e to the power minus x. Now if x tends to infinite, then in that case this expression will be plus infinite and this expression here will be 0. So if x tends to plus infinite, then phi also tends to plus infinite. Now as x tends to minus infinite, in that case here it will be 0 and minus, and it will tend to infinity. So if x tends to infinite, then phi also tends to infinite. So the correct option is, as x tends to minus infinite, phi also tends to minus infinite, and that's your option C. Now question number 22 is, we need to find this limit t tends to 0 f u plus tv minus f u upon t. Now u is 1 by 2 comma 1 by 2 and v is 3 comma 4. Now u plus tv, it will be 1 by 2 plus 3t comma 1 by 2 plus 4t. So we have to find this limit, which is limit t tends to 0 f 1 by 2 plus 3t comma 1 by 2 plus 4t and minus f 1 by 2 comma 1 by 2 by t. Now fxy is x square into y minus 1. So we can write this as limit t tends to 0 1 by 2 plus 3t whole square into 1 by 2 plus 4t minus 1, and then minus will be 1 by 4 into minus 1 by 2 upon t, which is the 0 upon 0 form. Now before taking L'Hopital's rule, we'll write this as 4t minus 1 by 2. Now we'll differentiate the numerator and denominator separately. We can write this as limit t tends to 0, and this is 2 into 1 by 2 plus 3t into 3, and then 4t minus half, and then plus 1 by 2 plus 3t square into 4 minus 0 upon 1. Now if we put t as 0, we'll get this as minus 3 by 2 and then plus 1, which is minus 1 by 2. So answer to this limit will be minus 1 by 2, and that's your option C. Now 23 is, we are given a real number alpha which lies between 0 and 1, and we have defined a sequence such that xn plus 1 equals alpha xn plus 1 minus alpha xn minus 1. Now what we'll do is we'll subtract xn. We can write xn plus 1 minus xn will be alpha minus 1 and then xn minus xn minus 1. Now in the same way we can write this as alpha minus 1 square into xn minus 1 minus xn minus 2, and if we continue this iteration we can write this as alpha minus 1 to the power n x1 minus x0. So we can write xn plus 1 minus x0 will be alpha minus 1 to the power n x1 minus x0. Now in the same way we can write xn minus xn minus 1 will be alpha minus 1 to the power n minus 1 x1 minus x0, and finally we'll get x1 minus x0 as alpha minus 1 to the power 0 x1 minus x0. Now if we add them all up, on the left hand side we can write xn plus 1 minus x0, it will be x1 minus x0 into 1 plus alpha minus 1 plus alpha minus 1 square up to alpha minus 1 to the power n. Now what we'll do is we'll take this limit n tends to infinite. So it will be this limit n tends to infinite xn plus 1 minus x0, and here will be x1 minus x0, and then this series which is nothing but an infinite GP whose sum is a upon 1 minus r, which is 1 minus alpha minus 1. So it will be x1 minus x0 upon 2 minus alpha. We can write this limit n tends to infinite xn plus 1 as x1 minus x0 upon 2 minus alpha, and then plus x naught. So it will be x1 plus 1 minus alpha x naught upon 2 minus alpha. x1 plus 1 minus alpha x naught upon 2 minus alpha, and that's your option B. Now question number 24 is, we are given two real valued functions f and g, and f is given by x upon x minus 1 for x greater than 1. Now if we subtract 1 and add 1, we can write fx as 1 plus 1 upon x minus 1, and it will be y minus 1 equals 1 upon x minus 1, which is shifted rectangular hyperbola. This point here is 1, 1. Now this function is clearly a 1, 1 function. Now we need to check if this function is invertible. Now the function is invertible if it is both 1, 1 and onto. Now for this function f, we are given the domain which is from 1 to infinite, but we are not specified any codomain. And when the codomain is not specified, we generally take this codomain as R. Now in this case, its range is from 1 to infinite, and its codomain is R. That means this function is 1, 1 and into. That means f inverse, it won't exist for f. Now what about gx? If we draw the graph of gx, it will be this graph. Now if we define g from R to R, in that case this function is both 1, 1 and onto. So in this case g inverse, it exists. So answer to this question should be f inverse does not exist, but g inverse does. Now the problem here is, in absence of any codomain, if we just have to check if it is 1, 1, then in that case we'll get this answer as D. So this question can have any answer, either C or D, depending on what we take as codomain of this function f. But according to me, better answer is this option C. Now question number 25 is, we are given this matrix A. We need to find number of element in this set A comma B belongs to Z square, where both A and B, they are greater than or equal to 0 but less than or equal to 2021, and we are also given that rank of A is 2, and if rank of A is 2, then determinant of A is 0. Now for this determinant, what we will do is we'll write R1 as R1 minus R3. So it will be A minus 1 0 0 and BA1 1 1 1 it will be 0. So from here we'll get A minus 1 square EB0, that is the value of A is 1. So there is only one way with which we can choose this A. Now since rank of A is 2, that means at least it should have one minor which is non-zero. So this determinant 1 1 B1, it must not be equal to 0, that is B is unequal to 1. So B can take any value from the range 0 to 2021 except 1. So that means we have 2021 choices for B. So number of elements in this set will be 2021, and that's your option A. Now question number 26 is, we are given this function f x minus y equals fx upon fy. Now this condition, it is satisfied by exponential function. So here this fx, it must be a to the power x. Now if we find f dash x will be a to the power x log a. Now f dash 0 will be a to the power 0, which is 1, and then log a, and f dash 0 is p. So from here we can say value of log a is p. Now if we find f dash 5 will be a to the power 5 log a, and it is q. Now log a is p. So from here we can write a to the power 5 equals q by p. Now we need to find the value of f dash minus 5. Now f dash minus 5, it will be a to the power minus 5 into log a. Now 1 upon a to the power 5 will be p by q, and log A is simply P. So this value will be P square by Q, and that's your option D. Now question number 27 is, consider the function f which is defined by fz equals e to the power z. Now for a real number c greater than 0, let a equals fz such that real part of z is equal to c. Now for this set A, we can write fz as e to the power c plus iota y, and which is e to the power c into e to the power iota y. Now in this case, its modulus is constant and its argument, it is going to vary. Now if modulus is constant and argument varies continuously, that means this set, it will be a circle. So this A will represent points on a circle. Now the set B is fz such that imaginary part of z is c. Now when imaginary part of z is c, we can write fz as e to the power x plus iota c. So it will be e to the power x into e to the power iota c. Now its argument, it is fixed. Only its magnitude can change, and when only magnitude changes and argument remains the same, it will represent a straight line. So this B, it will be a straight line. So answer to this question will be A is a circle and B is a straight line, and that's your option B. Now question number 28 is, two rows of n chairs facing each other are laid out. The number of different ways that n couples can sit on these chairs such that each person sits directly opposite to his or her partner. Now we have n pair of chairs and we have n couples. Now these n couples, they can be arranged in n pairs in factorial n ways. Now in each pair, we have 2 seats. Now on these 2 seats, any one couple can be arranged in 2 ways. So for the first seat, there will be 2 choices. For the second seat also, we'll have 2 choices. For the nth seat, we'll have 2 choices. So total number of ways in which they can sit is factorial n into 2 to the power n, and that's your option C. Now question number 29 is, a fair die is rolled 5 times. What is the probability that largest number rolled is 5? Now we'll find this probability by exclusion. We'll find the probability that largest number is 5 or less. If the largest number is 5 or less, then we have 5 choices each. So this probability will be 5 by 6 into 5 by 6 into 5 by 6 5 times. And then we'll subtract all the cases in which largest number is 4 or less. So if the largest number is 4 or less, then this probability will be 4 by 6 to the power 5. So this required probability is 5 by 6 to the power 5 minus 2 by 3 to the power 5, and that's your option D. Now question number 30 is, a circle is drawn with center at -1, 1. Let it be C1, and it touches this circle x square plus y square minus 4x plus 6y minus 3 equals to 0 externally. Then this circle touches which of the following options? Now for the second circle, center is at 2, -3, and its radius is under root of 4 plus 9 plus 3, and which is 4. Now if the two circles, they touch each other externally, then C1, C2, it must be equal to R1 plus R2. Now C1, C2 in this case is 3 square plus 4 square, and R1 plus R2 is 4. Now this is 5, so 5 equals R1 plus 4. R1 is simply 1. So radius of this first circle is 1 unit, and if the radius of first circle is 1 unit, then it is going to touch both the axes. So this circle, it touches both the axes, and that's your option A.